Today we continue with our data visualization subject, and we are discussing exploratory data analysis, abbreviated as EDA. So let's see what we are covering in today's presentation. From statistical point of view, the exploratory data analysis is an approach for analyzing data sets to summarize their main characteristics. We can use statistical graphs and other data visualization methods. The primary exploratory data analysis is for seeing what the data can tell us beyond the formal modeling just by looking at it, just by looking at the visualization. And therefore, what we discover might contrast the traditional hypothesis testing that is done in statistics. So the exploratory data analysis will help us to analyze and investigate the data sets and create a summary of the main characteristics with the visualization methods. Once we have an idea of what we discovered by looking at the data visualization to begin with, just as an exploration, we can make a decision and determine what is the best way to manipulate the data sources so we can have our questions answered or our goals achieved. What would make it easier to discover patterns, detect anomalies, or to check assumptions? So this approach, the exploratory data analysis, can help us to determine anomalies, certain patterns or trends, or whether this data needs to be pre-processed or augmented in any way before we start the main data analysis. Here are certain visualization techniques that we can use to explore the data through visualization before we start the main analysis. So, a technique of exploratory data analysis can help us to maximize our insight into the dataset. It might help us to determine the structure of the data, to determine which variables are important for answering our question or the goal of our study. Let's say our study is about patients in a hospital and how to heal particular disease such as heart disease or cancer. We need to be careful what variables we will use in order, first of all, to place a diagnosis whether they have cancer or heart disease, and second of all, what treatments are necessary to heal or cure that disease. So it is important to know which variables would help in our analysis to answer the question we have at hand. For example, the age of the patient is important, right? The older patients are more likely to have cancer or heart disease in the young ones. On the other side, the name of the patient is not important. Right? It doesn't make a difference how you're called and what our name is when it comes to cancer and heart disease. So we need to determine what are the important variables before we begin the primary data analysis. Detect outliers and anomalies. As we have, this is easy to detect with a visualization, as we already discussed in a previous lecture. If we are to just visualize the data, most of our patterns would be in the form of a dot or on our visualization. If this is a visualization where each data point, each data record is represented as a point, as we can see here, most of our data points are located in this area right here. And these data are plotted. That's a scatter plot visualization. This is called a scatter plot. By plotting our points like this, by just plotting the rent and the size, square footage, the numbers that they have onto our coordinate system of X and Y, so this is the X-axis, and the other one is the Y-axis, just a coordinate system. What we can see here is that most of our objects in our database appear in this lower left corner. So just by looking at this scatter plot, it is easy for us to find the outlier. Oops, I think I moved this out of view here. Here. What's happening here? Scatter plot visualization, it's easy for us to tell that most of the objects in our database are in here where the green circle is. And all of a sudden there is one point on the top right corner which is the only one that is there, and it is very far away from everything else. So by looking at this visualization, it is easy for us to spot the outlier or an anomaly. So that could be, for example, the patient that was recorded into our data. If let's pretend this is the medical data, we gave an example earlier that we want to determine if the patient has cancer or heart disease, and we're going to record their age as one of the important factors to determine this, most of our customers or our patients would be of age between, let's say, 30 to 80 or 85. All of a sudden, one patient is of age 300, a 300 years old guy. It's possible. Everything's possible. It's just very unlikely. And that's why this guy is sitting here on the top right corner, because the values of his attribute or his description is very different than the values of everybody else in our data. So just by plotting these values in a scatter plot like this, it is easy to tell where the outlier is. Alright, so we can detect outliers and anomalies. We can test assumptions. Test the underlying assumptions. And we can develop models and determine the optimal settings that we would like to use for our data analysis model. So let's look at some exploratory data analysis tools. Specific statistical functions and techniques can be performed with exploratory data analysis. So, for example, these are actual clustering is a machine learning method that is unsupervised machine learning method that finds groups of objects that are similar to each other in the data. And the only way that it finds them is really by looking at what we were just looking here. Compares their values. This little point right here has a value of 1000 on the x coordinate, and it has a value of around 2000 right here on the y coordinate. So the clustering to work, it's gonna look at this point to start with, and it will compare it to the point that is closest to it. That little point to the top left is the one that is closest to this one. So it will compare those 2 points and say how similar their values are. Pretty similar. This one is 1000 for x, this one is 1100 for x. This one is 2000 for y, this one is 2100 for y. Their values are pretty close. This means the 2 points are very close onto the picture here. So it will put them into the same cluster. Let's say this green one is the first cluster that it finds. So let me add something here. Let's say that this is cluster 1. And then finds another cluster. It's gonna, well, what I just said, it's gonna do this to every single point. It starts with this one, compares to the closest one, and then keep comparing to the next closest, the next closest, the next closest, to all, eventually to all the points into this data. So it's going to compare starting with the first one, then the second one, the third one, the fourth one, all of them. It's going to compare each point with any other point to determine how close they are to each other. And the ones that are close to each other will be placed in the same cluster or in the same group. So let's say it's going to find another cluster right here. And that will be called cluster 2. Maybe. Okay. And the outlier is sitting over here. So it's called unsupervised because we did not provide any direction to the machine on how to learn this. The only thing that it's doing is comparing the values of the points, and if their values are similar, it means they're close to each other and it places them into the same circle. And once it's done comparing each point with any other point onto the picture, it finds these two clusters. Now, there are certain methods, clustering methods, that we have to tell it before it starts how many clusters it wanted to find, such as the what is over here k-means clustering. This is a method which, before we start, we have to tell this method how many clusters do we want it to find. Now there are other, that's why it says into K groups. Now there are other clustering methods that would decide the number of clusters on their own. Those are called hierarchical clustering. So these clusterings are unsupervised machine learning techniques. Dimension reduction is also very important. We can look at the picture and our data, or a visualization of the data, to determine how many features, attributes, or descriptions do we have of our records, our objects. Let's say we were talking about medical record of patients and medical patients. We said there are certain attributes that will help us to determine if these patients have cancer or if they have heart disease. We have to look at carefully which ones we choose, because like we said, the age makes sense for determining if they have cancer or heart disease, but their name doesn't make any sense. That's not going to help us to determine person's name. That's going to help us to determine if they have heart disease or cancer. So we have to look at what do we have in our data. Is this related to answering our question or accomplishing the goal of our data analysis? If it is, great. If not, it has to be removed. First, because it doesn't make sense, but second, because if it's sitting there and it is not necessary, it creates computational complexity and increases the processing time of our data analysis methods. The more attributes, features, columns in the relational data that we have, that's called curse of dimensionality. The more attributes we have, the slower the processing time and the bigger complexity of processing complexity of our algorithm. So it's going to take a longer time to return the results to us, to make its prediction or to make its suggestion, or to decide the class, to make its suggestion to the user. Dimensions are the same thing as the features or the attributes or the columns into the relational data. A dimension is just an attribute or a column from the data. Over here we have a two-dimensional space. Why? Because we have only x and y coordinates. There are only two columns in this data. The first one is the size, square feet, and the second one is the rent. If there were three, we would have a z-axis in the back here, and we would have a three-dimensional space, x, y, z. So this point will have a third. Right now they have two coordinates. It will have a third coordinate in depth of what we see. And that's called three-dimensional space. Now, as you can imagine, in a data table, we can have a lot more than three attributes. And the more we have, that's how many dimensional space do we have. So, if there are four, we have a four-dimensional space. If there are five, we have a five-dimensional space. In my PhD dissertation, I had 48 dimensions in my data analysis. 48 dimensional space. So as you can imagine, the more dimensions we have, the slower it's going to run, because it's more complex and it takes longer time to finish the analysis. Because of that, this is critical right here. Dimension reduction. If some dimensions or attributes are not necessary, absolutely they need to be removed from the data. So, the exploratory data analysis can help us to determine this. Do we need this attribute or not? If not, remove it. If it is actually important for our answering our goal and the purpose of the analysis, then it needs to stay. So we can do certain visualizations, such as UniVariate visualization, which means each field in the raw data set is used and we create statistics for it. UniVariate means that there is one important variable that we care about. Let's say we want to know if the patient has cancer. So the cancer variable will be the one that helps us to make a decision, or that is the decision attribute that is important to us. We could have multiple such variables that we are interested in determining, and if that's the case, we will have a multivariate visualization. Okay, so specific statistical functions and techniques can be performed with exploratory data analysis. The first one is the cluster, as we mentioned. This cluster may be visualized, and even if it is not visualized, we can, as a graphical visualization, we can still tell how close the objects are to each other and whether they're in the same group or cluster. Now, if we're using graphical visualization, we can have the scatter plot that we have seen just with our example. There are other plots such as stem and leaf plots and histograms. We have seen those in the previous lecture. The histogram is going to show us the frequency or count of how frequently particular item occurs in our data, for example, or how frequently particular variable value occurs in our data, so the histogram is a frequency visualization. And then we can use box plots. That's a visualization that will include a median, as well as minimum and maximum values, and a few other critical points in between them. So with the box plot, we will have minimum, maximum, the median point, and some other ones in between, like first quartile and third quartile. So these are specific tools that can be used. When we're having multivariate and we would like to know several variables versus just one, we can have a grouped bar plot, what is also called a bar chart. So we can create a bar chart for each group or cluster that represents one level of one of the variables. So a bar will be showing one level of one of the variables that we're looking at, and we will have several bars, each one representing the levels of the remaining variables. With univariate analysis, we said that they will have a single attribute or a decision attribute or a variable that we're interested in for answering the question or the goal of our analysis. One of them we gave example was, does the patient have cancer or not? Does the patient have heart disease or not? Other examples here, from, let's say, from retail business, from business data. What is the price of a rental in New York City? What is the typical price of a rental in particular location? What proportion of the rentals have a gym? So the univariate analysis will have a single variable that answers a single question that we're interested in. Okay, so coming back to our scatter plot here. As we mentioned earlier, the way this plot is created is by taking the x and y values. X is the size square feet, y is the range of one data item, record, or object in our data, and plotting it, just plotting it into the coordinate system. This is the first object, that little dot right here. And the rest of the dots are plotted into this visualization in the same way. Okay, so as we mentioned, by looking at this, we can find clusters by determining how close these points are to each other. For example, K-means clustering or hierarchical clustering, but also density-based clustering, because we can see this green circle right here has very dense population of objects. The objects over here are very, very close to each other, and it's a lot of them into this green circle. The yellow circle is twice as big as the green, but it probably has the same number of dots in it, just because they have more space in between them. So we can also find clusters based on density. When a region is highly dense onto the visualization, we can group those into a cluster. And um, finally, the outliers would be points that are single or alone or very far away. This is another outlier from the rest of the data points, from the usual values of data points in this particular data set. So when we have multivariate analysis and we want to observe more than one variable at a time on our visualization, then we are simultaneously exploring the relationship between one or more variables. In a single visualization. And the reason we're doing this is because one variable might be correlated to another variable. If one variable changes, another one changes. Let's say the patient has heart disease. So certain treatment needs to be applied. Well, the treatment was applied to the patient, and now the heart disease is healed. So the treatment is correlated to the heart disease condition, and it makes a change. Before the treatment, person had heart disease. After the treatment, they don't have heart disease anymore. So that's why we would like to explore the relationship between variables. How does one variable affect another, or maybe two others? When doing data analysis, we normally assume that the variables are not correlated to each other, but the truthful reality is that they are correlated. One variable can make, with its changes, it can trigger change into another one. Another example is, let's say, student is studying right now, but next semester student graduates and gets a master's degree. Well, what was their income while they were students? Their income can change because they got the master's degree and now they have a higher income. So that's another example of how one variable can affect another variable. So it is safe to say here that the variables can be correlated, and that is why we want to look at more than one variable. maybe we should make this one yellow. Okay, so to do the multivariate visualization, we would visualize, we can use colors, we can visualize certain variables or attributes with specific color. So what we see the color here, one is violet, 0.8 is a lighter violet, 0.4 is pink, and 0 is white, and then it turns into a green. So we are using colors in between violet and green in this visualization, depending on what is the value of this variable. What you would observe here is there is a violet diagonal. All of the squares onto the diagonal are violet. This means they're equal to 1. The reason for this is called a decision matrix. What we're doing here is comparing each on the left on the x coordinate and on the bottom on the y coordinate. We have the exact same attributes or variables. What we're doing here is telling what happens if we take rent with rent together. If those two occur together, what happens? Well, rent is the same thing as rent. So the distance between rent and rent is 1, or the difference between rent and rent is 0, because they're the same thing. Rent is the same as rent. That's why we have the diagonal here is not used. All the diagonal values are equal to 1. Now the next one though, bedrooms with rent, that has a different color. Minutes to subway with rent, that has a different color. How does the rent affect, how do the minutes to the subway affect the rent of this apartment? If the apartment is closer to the subway, it's easier to walk to the subway, it will have a higher rent. If it is farther from the subway, it will have a lower rent. So that, coming back here, there is a correlation between the rent and the distance from the subway. Okay, so this matrix here is showing the correlations in between those attributes. What is the correlation between the rent and the age? When was this building built? Well, if it's an old building, the rent will be lower than if it was a brand new construction, brand new building. Another thing you would notice here, the top of the matrix above the diagonal is the exact same thing as the bottom of the matrix that's below the diagonal. So we don't really need what is above the diagonal. We only need the lower part here. Okay, another way that we can plot 3 variables in this case. We are using lines, and those lines can separate the scatter plot objects into 3 planes or classes. So what we can see here is the students that completed 1 assignment, their score or their grade would be lower than students who completed 5 assignments. So 1 assignment is the light blue line, 5 assignments is the violet line, and so the violet line students that completed 5 assignments will have a higher score than the blue line that completed 1 assignment. And students who completed even 10 assignments would have a much higher grade than the previous 2 categories. So that is what this particular visualization is showing. Okay, so today we have looked at exploratory data analysis, visualization of clusters of single variate and of univariate with single variable and multivariate with multiple variables, as well as the correlations between the variables. So that is all that we have for the exploratory data analysis